Okay, now let's take a look at the natural logarithm. The natural logarithm is the second kind of logarithm that we're going to be talking about in this course. So when e is used for the exponential function, it's actually easier to use a log that is base e instead of the base 10 log. So our definition would actually say that for x greater than 0, y equals natural log of x. It is the power of e that produces x. In other words, if y equals natural log of x, which we write as ln of x, then if we were to convert that to an exponential, that would actually tell us that x would equal e to the y. So if I take the natural log of x, what happens is the result of that would be the exponent on e that would produce that x. Not nearly as intuitive as working with powers of 10 because we're much more comfortable with 10 to the first and 10 to the second, but the concept works the same way. Remember the rules we had when we talked about log, log log? Well, we have a couple of similar rules for natural log. In a similar fashion to what we saw, we have the natural log of e to a power. So if I take the natural log of e raised to something, the natural log and the e behaving as inverses will produce just the p. Similarly, if I have e raised to the natural log of a power, those also would behave as inverses and would give us just p, so long as p is greater than 0. So let's take a look at a couple of examples, or maybe I should say an example. And this is a tricky one. This always gives people trouble. So if I wanted to simplify e raised to the negative 3 natural log x, what I'm going to use is some natural log rules or some log rules, which we're going to see in a couple of minutes, but I know from what we talked about before, many of you are familiar with these rules. E to the negative 3 natural log of x, one of the rules and one of the properties that we're going to expand on says that we could actually take that negative 3 and bring it back up onto the natural log of x. And so e to the negative 3 natural log of x, we could actually rewrite as e to the natural log of x to the negative 3rd. Now we're in the form of our property b up above, and so e and the natural log cancel each other out, and we get x to the negative 3. Notice it is very, very, very important that if you want those cancellations to occur, that the e and the natural log have to be in one of those two positions. So if it's e raised to the natural log, there can be nothing between the e and the raised two parts. That's why I had to move the negative 3 first. Similarly, if I had natural log of e to something, the natural log has to be immediately followed by the e. So that'll be critical. You can't do the cancellation until we many times do a little rewrite.